Let's begin. Who's my favorite student? I am, Mr. Duick. Who's my favorite student? Good old Anne. Gets everything right. All right. I'm going to be fussy on the second part of number one. Number one is 2 marks, so 2 things. Absolutely. What's the unit of force? So if you wrote a capital N, I'll take that. If you wrote the word newtons, I'll take that. Definition of a force. What did you say? I will absolutely accept. Anybody say anything else? That which causes a mass to accelerate would be a good definition. That would be using Newton's second law and Bryan's version of rewriting the equation. Sure, I would absolutely take that. The thing that causes masses to accelerate. If you get into quantum physics, I think we would say it's an interaction between 2 objects that exchange bosons, I think. If you really want to dive down there, and if you said that, I'd say nerd, but I'd give you the full marks. I'm guessing most of you just said push or pull. Not a great definition, but it's pretty good, Tristan, and I like it because it's fairly obvious when it's happening. What word did I underline? I said to you last day, that's a clue, a code word. If I ever say net force for 1 mark, I'm saying you can go straight to Newton's second law, F equals ma. They're asking me to find the force. It's going to be 1,200 times 2. Is the answer 2,400 newtons? I think so. 1 mark. Number 3, more than 1 mark probably means more than 1 step. Now, they want me to find the force on the shell, and I think I told you I'm really talking about the net force. I'm going to go like this. F equals ma. Do I know the mass of the artillery shell? Yep. Do I know the acceleration? Nope. And that's why I said, hint, you're probably going to need to find the acceleration first. So I'm going to draw a little line here, and I'm going to say A equals question mark. It looks like I see a V final of 770. I see a D of 1.5. What else do I know? Oh, what's VI? Did they say starting from rest? Which I'm going to suggest next time, I don't think I need to tell you for an artillery shell. I think it's fair to assume that any gun or artillery shell ever starts in the barrel from rest. Is that okay to expect you to reason your way to, Maggie? I think I'm going to go with that from now on, but I did this time. A equals VF squared minus VI squared all over 2D. It's going to be 770 squared minus 0 squared all over 2 times 1.5. A equals, is this a fraction? More than one thing on the top? Brackets. I got an extra 7 in there. Whoops. By the way, do I really need to type minus 0 squared? So can I skip that? It's not going to change anything. I'm going to skip that. Divided by, I might even be so lazy as to say 2 times 1.5 is 3. And if you're comfortable doing basic math in your head, go ahead. On a test, I probably wouldn't. I'd still hedge my bets and crunch it on the calculator. Now, at first, I started to freak out because that's a really big acceleration. But then I said, wait a minute. It's a gun. I think it should be a big acceleration. I'm okay with that. I'm going to write 198 and 4 zeros. 3 zeros? 198 and 3 zeros. That's what I said, 3 zeros. Meters per second squared. But I'm not going to use this number. I'm going to use the number stored on my calculator. So now I go walking all the way over here. F equals 65 times, I'll write 198 with 3 zeros. But I'm going to go this number times 65. Do you get? 12846. I'm going to write this. You know what? I think I'm going to write this in scientific notation because this is big. 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7. What did I say? 1.2 8 times 10 to the 7th newtons. If you didn't write it in scientific notation, after the 8 you would have 1, 2, 3, 4, 5 zeros or 5 digits, and I'd probably round off to 3 sig figs because how accurate are we going to be here? Is that a big force? It's a cannon. It should be a pretty big force. Because also, when that hit an object, it would apply a very similar force to that object. Would it do damage? Well, heck yeah. It's a cannon. It has to do damage. If you got that right, 3 out of 3. Otherwise, I would probably give you a half mark for writing F equals ma. I would give you 1 mark if I saw Vf squared minus Vi squared all over 2D. I would give you 1 mark for the acceleration, and then I would give you a half mark for the answer. There's your 3. Cole, what word is underlined? What word did I underline in number 4? What do they want me to find, Brian? In number 4?
Oh, acceleration.
Can you give me your equation?
A equals F over.
Yeah, I'd do that. Did they give me a force? 12. Did they give me a mass? 1.2. Does this work out to 10 even? Wow, that was nice making things work out evenly for you folks. 1 mark. Next page over. Also 1 mark, they want the average acceleration. I'm seeing velocities and time. I think I'm going to find acceleration not using Brian's equation. I'm going to find acceleration using the stuff from pre-Christmas. I see a t of 32. I see a vi of 0. I see a vf of 3.2 times 10 to the 4th. I'm going to use a equals vf minus vi over t. It's going to be 3.2 times 10 to the 4th minus 0 all over t. You get 10 to the 3rd. You get 1,000? No? Yes? Am I right? Okay. 1.0 times 10 to the 3rd. What's the average net? Average net force? I'm going to go straight to F equals ma. So it's going to be 4.5 times 10 to the 4th times 1,000. I think you're going to get 4.5 times 10 to the 7th newtons. You're going to get a 4, a 5, and 6 zeros after the 5. Yes? No? Yep. 1 mark. How far did the object travel while accelerating? So they want me to find a distance, and it's 2 marks, which suggests maybe I'm going to find something in order to find something. Well, I see VI is 0. I see VF is 12. What else would I like if I wanted to find D? Time. What else would I like if I wanted to find D? Because I can't find time right now. Did they give me a force? Does that mean maybe I can use Brian's equation to find? So I'm going to say A equals, and in my notation, if it's a second thing I need to find but not the main thing, I just put a blank, like I need to fill that blank in to answer the question mark. Come up with whatever works for you, David, but you know I tend to abbreviate. This is what I've evolved in my notes over the years. Whatever works for you, as long as you're getting this right, Tristan, I don't care, as long as it works for you. So I'm going to make a little note here. A equals F over M. The force that they gave me was 1.6 newtons. Oh, this is moving all over the place. The force that they gave me is 1.6 newtons. The mass that they gave me is 6.4 newtons. Do you get an acceleration of 0.25 meters per second squared? If I do that in my head, yes, 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 or no? Yeah. Yep. And then I walked that over there, and I said D equals VF squared minus VI squared all over 2A. It's going to be 12 squared minus 0 squared all over 2 times 0.25. I think I can do this in my head as well. It's going to be 144 divided by, it's going to be, is it 288? Yes? meters. If you got that right, Hannah, 2 out of 2. Otherwise, honestly, for 2 marks, I'd probably give you 1 mark for the acceleration and 1 mark for the distance. Cole, what do they want me to find in B? That's also how I knew I wasn't going to find time in order, because they're asking me to find it later on. Okay. You know what? I'm going to wimp out. I'm going to go with T equals VF minus VI over A. Will that get me there? Now, I'm going to use my A answer from part A. Whatever. It's going to be 12 minus 0 all over 0.25. Y'all get a time of 48 seconds or not? Is that right? No? Yes? Yes?
Yeah.
2 out of 2 for that. Honestly, I probably should have made B 1 mark, but okay. I would give you 1 whole mark for that and then 1 mark for the answer. Did anybody use a different equation to find time? You could have used T equals the square root of 2 times D over A. That would have gotten you there. You could have... There's others. Which one did you use? You got the same answer? Yeah. Did I do less work than you? Ha ha! Okay, turn the page. Which of the following statements are true? Jacqueline, how many questions are there in number 7? How many marks is it worth? Would you suggest a half mark for each question? Hey, now you know how I'm thinking. True or false? There are no forces sitting on your binders because they're not accelerating. That means there's no forces acting on them. True or false? False! Absolutely. Oh, do it in red, Mr. Duke. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force of the book. True. That's a long way to say if it's not accelerating, the forces must be. I'm looking for a word that begins with a letter B. Balance. Okay. So true. The net force on the book is equal to 0. True or false? How do you know? Is it accelerating? Then the net force must be 0. That's the power of Newton's first law. Friction is what's holding the book on the desk. Oh. If I'm not sure about friction, my go-to mental method is I'll replace the surface with ice and ask myself if it still works. If it still works, it ain't friction. If your desk was completely flat and made of ice, could a book still sit on there? Yeah. If it was tilted, it would slide off, but that's not what this question says. It says it was a... I put that word there on purpose. So is friction what's holding the book on the desk? So F to the 2 marks. I like example 8, I like example 8, I like example 8. Example 8 is a nice question. A 60 kilogram person stands on a scale that reads the normal force in newtons. If the person, by the way, I probably never again will give you that phrase after the word scale. I'm going to assume from now on, Emma, when I'm talking about a scale, you'll say, dude, you're not talking about a scale, you're talking about the normal force. So I'm not going to give you that hint anymore. It wants to find the scale reading. It really wants to find the normal force. How will I do A? You know what I would do first? You know what this is a job for? Free body diagram. How do I know? Because there's more than one force in this question. They're asking for the normal force, and I know there's mg. Probably worth doing an FBD, a free body diagram. So here's the person. What are the forces acting on them? Get the obvious one. What else? Normal force, bigger, smaller, or the same size as mg. Which way are we accelerating? Up. Which way must there be a bigger arrow pointing? Up. So I'll really exaggerate it. Yoink. Nick, what's my equation going to be? Who's winning?
FN.
Who's the loser? What does winner minus loser always equal? It might not be in your notes. What does winner help me out, folks? What does winner minus loser always equal? MA. What am I trying to find here? the scale reading. What am I really trying to find here whenever I'm talking about a scale reading?
Normal force.
Yeah. How do I get the Fn by itself for this equation? Add what? More nouns, please.
The F1.
I want to add the Fn. What's right?
G.
Yes. You awake now? I know I'm picking on you. You're zoning out. So you're telling me it's mg plus ma or ma plus mg? I agree. Nick, what's the mass?
60.
What's g?
1.8.
Do I need to put the negative in here? I've taken care of that. In fact, the negative showed up right there. See it, see it, see it, see it, see it, see it, see it. Plus 60. What's a?
1.1.
Which is what? Is it going to be 660? No, yes? B. This is a job for a free body diagram. What are the forces acting on this object? Get the obvious one. Gravity down. What else? There is a normal force, bigger, smaller, or the same size as mg. Which way are we accelerating? Down. Which way is winning? Down. Which way is the longer arrow? Down. So normal force is going to be smaller. Still there. Christian, what's my equation here going to be? Who's winning? Who's losing? What does winner minus loser always equal? What do I want to get by itself? No. I know mg. I could have just gone 60 times 9.8. What's it wanting me to find? Ah, thank you. Scale reading, normal force. What's right in front of the Fn that I don't like? I'm going to do what I've nicknamed, what one of my students nicknamed the swappy dance. So I'm going to plus this to there. At the same time, I'm going to minus the MA to there. Why minus the MA? Because in front of the MA, there's a little visible plus sign. It's positive. So I'm going to get this. Mg minus Ma. And do you mind, Christian? I'm going to put the normal force on the left-hand side by itself because that's kind of where we're used to seeing the thing by itself. What's M? G minus 60. What's A? $60 times 9.8 minus 60 times 2.25. Do you get 453? Yes? What if instead of asking you for the normal force, what if I asked you for the scale reading in kilograms? How can I convert that into kilograms, the equivalent? Divide by? Not divide by 3 point something. Yeah. Divide by 9.8. In other words, if this was a bathroom scale, not a Newton scale, when he was in this situation, Cole, instead of reading 60 kilograms, the scale will be reading 46.2. Does this person feel heavier or lighter? Don't overcomplicate it. Does this person feel heavier or lighter? Yeah, way lighter, but almost a third lighter. That would get your attention. You would feel that. Wow, you'd feel like, you know what? Every one of you would feel like they could jump really high. They would feel like they had hang time. Every one of you. Oh, sorry, I don't know where that came from. Some of you might even be able to duck. Okay. C. What's the key phrase in C? Phrase, not word. Key phrase in C. Constant what? Ah! What does that tell me? Tells me A is 0. So in my free body diagram, gravity down, even though we're moving up, since A is 0, it's a tie because you're not accelerating. So what equation can I write out of that? If it's a tie, What equation can I write out of this? Yep. In other words, if you're moving at a constant speed, can you feel it? Is there any experiment in the universe that can prove whether we're moving at a constant speed or at rest? Einstein said nope. We can feel acceleration. That's why he had to come up with an entirely new theory of general relativity to bring acceleration into all the time dilations. That we can feel that. But if you're going at a constant speed, Emma, we have no experiment in the universe to prove it. If you're in a locked elevator that's traveling that has no windows, that's traveling at a constant speed, prove it. You can't. You can't. You can't. Here it's going to be 60 times 9.8, which is going to be 700 minus. Is it going to 688? 688? No. Yes. Am I wrong? Sorry. I might be wrong. Sorry, 6,468. Is that better? I forgot to carry a zero. Is that right? No. It's not 660. It's 60 times 9.8. I typed an extra 6 there. 500. Didn't I say 588? Or did I say 688? 588, Mr. Dewitt. 588. Carry a 1. Jeez. Last one. Suppose the rope is cut and we're in free fall and we stand on the scale. What will the scale read? 0. If you just said 0, 2 marks. Can we prove it? Yeah. Who's winning? Gravity. Who's losing? Normal force. If you solve, gravity minus normal force equals ma. If you then do the swappy dance to get the normal force by itself, you are going to find the normal force equals 0 newtons. For all of these, if you got the correct answer, 2 out of 2. Otherwise, I would give you 1 mark for that equation and then 1 mark for the answer. Except for the very last one, if you just got the right answer, that gets you 2 out of 2, because some of you may have been able to do that intuitively. Can you give yourself a lovely score out of 23? And if you need to come lawyer with me, now is the time.